Good evening, sir.
Good evening, Harshit. Who else is there? I see Samrat and Harshit.
Hello, sir.
Hello, Samrat. How are you?
A little bit fine, I guess.
Little bit fine, not fine.
No, fine. I was going to say something. It's fine.
Okay. When is this starting? When is your exam starting?
September 14.
September 14. And what is the first paper?
English.
First is English, is it? Hello?
Yes, sir.
Yeah.
Yes, sir.
I'll just wait for others also to come. Okay. Okay, so let's start.
So even Samrit left.
Samrit left, is it? Never mind. He can join in later on. So let's start with, what happened to Anirudh? Never mind. So let's first of all write down the topics which are there, and and let's try and understand what all topics are there, and then let me try to cover as much as possible for today's session. So I think in most of all the NPCs the same topics are there, I believe. So let me list them down and tell me, guys, if these are not there. So we have real numbers. Yeah, real numbers, and then you have in algebra you have. Sorry, Samrit, you're saying something.
Yes, sir. Anirudh asking you if you could invite him.
See, I just shared the link. You have to just click on that link. That's it.
So he's having a little problem with the link itself. So that's why, sir. He shared a
Uh,
picture.
yeah, ask him to, he can also watch it on YouTube otherwise, or he can send me his email ID. Okay, but yeah, so let me start with yeah, so this is what we were doing. First is real number, then we have polynomials, and then we have pair of linear equations, pair of linear equations. These are the topics, and then what all? These are there included in the exam. This exam, right?
Yes, sir.
Yeah. Okay. Great. So, and what else? Can you just take me through, Harshit?
So 1 minute, I'll just get my textbook.
You please get the the syllabus so that we can discuss that only. Okay. So Anirudh is facing trouble. I'll just add him just a minute, and then okay. So I'll add him. Yeah, you can tell him that I have sent him an invite, so he must be on now. Never mind. So,
Yes, sir. So
yeah,
there's real numbers, polynomials, pair of linear equations, and two variables. Then there's triangles.
triangles. Okay. Then trigonometry.
Introduction to trigonometry. Then
Okay.
then constructions,
Constructions.
and then statistics and probability.
Construction, and oh, sorry, this is 5. This is 6. Construction 7. Construction, and then what? Statistics and probability, right? Statistics, and probability. And in Rajajinagar we have matrices as well. So these are the topics. Obviously, we'll not be able to cover all of them in the same session. What we'll do is we'll plan more such sessions in future. Let's say before your exam, so that entire revision in mathematics can be done. So I believe let me just start with which topic do you want me to take. So let's do one thing. Let's prioritize first. We'll just plug the low hanging fruits first, so that at least that level of confidence is there. So what I would do is, let me quickly revise this first, because here is one critical thing.
So we did this for the previous exam, sir, so it'll be easier for us.
No, so what I'm which other one you want to revise? Shall we revise real numbers?
Triangles and trigonometry.
Trigonometry and triangles. So let me start with triangles, because I had done a revision on trigonometry yesterday for Rajajinagar people. So this is, I don't know if you know that this is a live session, and across NPS class 10 students are watching it. So yesterday I did a bit of revision of trigonometry. Today let me start with triangles, so that there is no overlap, and then we'll take up trigonometry in the next session, or if time permits, today itself. So in triangles, give me a moment, please. Just a minute. I'll remove all those disturbing elements. No, just a minute. Okay, so yeah, just so there is a yeah, I'll have to keep track of the messages which are being sent also. So just give me a moment, please.
So I'll tell you when any messages are there.
Yeah, so anyone is watching on YouTube? So because there I would be receiving few messages, so I need to know. Anyways, I'll try myself. No worries.
So in YouTube, what do we have to search?
Centum Academy. Great. So lots of people from Rajanagar have logged in. So I think we can do a good session. So let's start. Okay. So here is our first thing on. Let's say let us do triangles. So we are going to start with triangles. Okay, triangles. So do you guys remember what all topics were covered in this chapter? So we started with a very basic proportionality. You remember the theorem,
That's
uh,
BPT.
BPT, and there was a proof to it, and there was a converse to it as well. So let me list down the topic so that it becomes a very structured way of doing it. So hence, in triangles we had Thales theorem. So something called Thales. Yeah, Thales theorem, or we call it basic proportionality theorem. Yeah, this was the first theorem which we studied during our sessions on triangles. Okay, now, so what was Thales theorem? And Thales theorem was something like Thales theorem said that if you have a triangle, ABC, and if a line is drawn parallel to one side of the triangle, let's say the BC is the side, and I am drawing a line parallel to BC. So we say DE is parallel to BC in triangle ABC. Then by basic proportionality theorem, we learned that AD upon DB is equal to AE upon EC. This was the first theorem which we learned, which is called Thales theorem. Now, so you remember how did we prove that time? So basically, the proof of this was dependent on, or let's say, proof was done on. We used areas of triangle. Proof was based on areas of triangles. Areas of triangles were used, and what did we do? We just simply dropped a perpendicular from E to AB and from D to AC, like that, isn't it? And then we also joined BE and CD. Now, in first case, we took this shape, basically this one, and this was the diagram. Let's say this is my A, this is D, this is E, and this one is B. And we had dropped a perpendicular onto AD, and let's call it L, or let's say P. Okay, and then what did we do? We found out the ratios of the area of. So we found out this area of triangle ADE divided by area of triangle BDE, and this was nothing but half into base into height. So half into base was AD, and into height was PE, and similarly here it was half into base in triangle BDE is BD, and my height will be same as PE because that's the altitude from E on to AB. So if you see, we canceled PE out, and then half also gets cancelled. So what is left? What are we left with is area of triangle ADE divided by area of triangle BDE is equal to AD upon BD. This was our first step. Similarly, we had taken this triangle. Which triangle? This one, and then yeah, like that. And this is my another part of it. So, and we dropped a perpendicular like that. This was point A. This is E. This is D. This is Q. Let's say this point is P, and this point is Q. So Q, and again, this was perpendicular. So hence area of triangle, again, ADE upon area of triangle. Let's say this point was C. So DEC is nothing but half into base. So this one is base here. AE into height. Height was DQ upon half into what is DEC area. Area is, this is base. If EC is base, and DQ is perpendicular again. So DQ gets cancelled. Half gets cancelled, and we get area of triangle ADE upon area of triangle DEC is equal to AE by EC. So if you see, these are the two relations we got, ADE, and then what did we do? We just now if you see, triangle area of, let's say this is 1 and let's say this is 2. So from another thing which we observe is triangle area of triangle BDE is equal to area of triangle DEC. And why is that? Because if you see which two triangles we are talking about, so we are talking about this one, and we are talking about this one. Yeah, both the triangles are having the same base. And what is the base? Base is DE. Base is DE. So I'm multiplying half into DE. And if you see, what is the, and since they are between the same parallel, because DE is parallel to BC, so hence height would also be same. So hence, let's say that height was, let's say if this height was H, similarly this height will also be H. Okay, so hence this becomes half into DE into H. So in both the cases, the areas are same. So from 1 and 2, we see that left-hand side of 1 is equal to left-hand side of 2. How? Because the numerator is same and the denominator we just proved are also same. So that means from 1 and 2, it follows that AD by BD will be equal to AE by EC. So this was what I was supposed to prove, that if there is a line parallel to the third side of a triangle like that, then the ratios in which they will divide the other two segments will be same. So AD by BD is equal to AE by EC. Okay, guys, any doubt, any whatsoever, please keep commenting on the YouTube comment section. Yeah, so next. So this was the first one, and then there were so many corollaries to it, and where we used the concepts of componendo and dividendo. Componendo and dividendo to find out other corollaries. So for example, the same thing. So AD upon, I'll redraw the triangle in front of you so that it becomes easier. So let me say, yeah. So wait a minute. So what I'll do is I'll take this diagram here. So let's say this is the diagram here now. Okay, so let me pull it here. Now, what did we just prove? We proved AD by DB equals AE by EC. AE by EC. This is what we proved. Now, if you add 1 to both sides, you will get AD by DB plus 1 is equal to AE by EC plus 1. Taking LCM, you will see this is DB, and then on top this is AD, and this is, if you do the calculation, it will be DB here. This is equal to AE plus EC upon what? EC. Yep. So AD plus DB by diagram, if you see AD, what is AD? AD plus DB is nothing but AB. So hence it becomes AV upon DB is equal to AC upon EC. This is the corollary to BPT. Similarly, you can invert, just reciprocate it. You will get DB upon AB is equal to EC upon AC, and then if you do this operation, 1 minus this on both sides, you will again get what? AD upon AB is equal to AE upon AC. So these are the different corollaries to the same basic proportionality theorem, and then we had seen what? Converse of BPT. Converse of BPT. And what does it say? That if in a triangle if in a triangle, let's say ABC, a line divides the two sides in such a way that AD by DB is equal to, let's say it's given that AD upon DB was equal to AE upon EC, then you have to prove that the converse of BPT says that DE will be parallel to BC. This is you have to prove. And how did we prove that? We actually used contradiction method. Now that we know BPT holds, we will say that, okay, let's assume that DE is not parallel to. So we will prove by proving by contradiction. And what is that method? We start with an assumption and eventually prove by mathematical operations that that assumption is not correct, is not valid, and hence we say that since the assumption was not correct, so hence it's not true. So what? So how do we do now? So basically, what the step is? Let's say that DE is, let's say, so we assumption is, let's assume assumption is that, okay, let's say that DE is not parallel to BC. So DE is not parallel to BC. So BC is a line, and so we must have another line DE dash, which must be parallel to BC. Yeah, there could be one line DE dash which must be parallel to BC. So let that line be DE dash. Now by BPT, we are saying that in triangle ABC, we are saying that AD upon DB is equal to AE dash upon E dash C. Why? Because by BPT, since we assumed that DE dash is parallel to BC, hence this should hold. But given was, what was given? Given was that AD by DB is equal to AE by EC. AE by EC. That means from this one, so let's say 2 and this 1, I can say that AE by EC is equal to AE dash by E dash C. Okay. Now what's the next step? Let's add 1 to both sides. You will see AE by EC plus 1 is equal to AE dash by E dash C plus 1. Okay. Now why did I add 1? It will be clear in the next step. So if you add now and then simplify, it becomes AE plus EC divided by EC, and hence it becomes AE dash plus E dash C divided by E dash C. Now from diagram, if you see what is AE plus EC, let me again pull this diagram near our calculations so that it becomes easier for all of you to relate to it. Okay, so what I'm doing is I'm now pulling it here. Yeah, so if you see what is AE plus EC, AE plus EC is nothing but AE plus EC is nothing but AC, and then in the denominator it is EC itself, and on the right hand side AE dash plus E dash C will be AC again, and in the denominator it is E dash C. So from this we get EC is equal to E dash C. Now how can EC and E dash C be different if E and E dash are two different points, if they are, and that too they are lying on the same line? So that means E is nothing but E is same as E dash. E is same as E dash. That means DE dash, which we assume to be parallel now, so hence DE dash must be parallel to, or DE dash is equal to, DE dash is nothing but DE, so hence DE is parallel to BC. This is the converse of Thales theorem. And then the first set of problems will be around this, and you can take up a simple problem, and let's see if we can. There will be questions like where you would be given questions. Type of questions will be something like that. They will give you two parallel lines in a triangle. There will be parallel line. One line will be parallel to the third side, and they will give you, let's say, the values like this is 5, this is 7, and let's say this is 10. So what will be this? So you can very easily calculate. Many a times they will give you on corollaries. So what they will do is they will give you a triangle. A line will be parallel to the third side, and they will not give you the parts, but they will give you, let's say this is 12 and this is 3, and let's say they will say this is 9, and find out dB. So this is what. So again, you will have to just simply take the ratios and figure it out how. So dB upon AB is equal to CE upon AC, and this is by corollary to BPT. And hence you deploy the values. dB is what you need to find out. AB is 9, CE was given to be 3, AC is 12. So you now know dB is equal to 3 upon 12 into 9. So this becomes 4. So it is nothing but 9 by 4. So far so good, guys. Any question here? Yeah, so this was.
There are some messages on YouTube.
Okay, is it? Let me just have a look, and so that I can answer these queries. So what are the queries? Yeah. Yeah. Never mind. So there is no question as such. Yeah, there is no question. So on YouTube also, people have not posted any questions. So as of now, never mind. So let me go and give you another problem on BPT, and let's see if you are able to. And we will not spend much of a time in, let's say, giving you, or let's say making you do it. What I'll do is I'll quickly solve the questions, and so that you remember what are the do's and don'ts of solving problems of BPT. So now the question goes like that. Question is, in a triangle ABC, D and E are 2 points on AB such that AD is equal to BE. If DP is parallel to BC, and EQ is parallel to AC, then prove that PQ is parallel to AB. PQ is parallel to AB. So let me draw the figure. So let's say there is a triangle. Let me draw a triangle quickly. This is A, this is B, let's say this is A, B, and C. And they're saying D and E are 2 points on AB such that AD is equal to BE. Okay, so let's say D is a point here and E is a point here, and they say AD, so this is equal to BE. If DP is parallel to BC, so let's say DP is parallel to BC, and EQ is parallel to AC, EQ, so this could be EQ is parallel to AC. You have to prove that PQ is parallel to AB. Yeah. So how do we do it? So again, the moment this is how you should be thinking. So let's say this is a problem given in triangles, and in triangles, the first thing which we have learned is BPT, and BPT requires having sides parallel to the sides of the triangle, or some lines parallel to the sides of the triangle, which is given over here. So let's use that and see whether we can use it. So it's given that DP is parallel to BC. So by BPT, I can write AD upon DB is equal to AD upon DB is equal to AP upon PC. Now always remember, they have asked you to prove PQ is parallel to AB. Now PQ is parallel to AB only when you will get CQ by QB is equal to CP by PA, or basically CQ upon CB is equal to, let's say, CP upon CA, then our problem is solved. So always keep in mind that what exactly is your destination. So this is my destination. I have to arrive at this point. Yeah. So hence I have to make sure that I am dealing with quantities which are there in this final end. So hence I will modify this and I will write, so AD upon AB will be equal to AP upon AC. AC. Yeah, this is also true by corollary of BPT. Okay. Okay. Now, so what next? So also it's given that EQ is parallel to AC. So now EQ is parallel to AC. So hence what we can do? We say BE by, again AB I will take full, and then it is equal to BQ by BQ upon BC. BQ upon BC. Now it was given that AD and EB are same. AD and EB are same. So if you see this 1 and 2, the LHS are same. So LHS of this is AD upon AB, and LHS of second equation is BE upon AB. And you know that AD is equal to BE given. That means both the LHS are same. That means I can equate the RHS and I get AP by AC is equal to BQ by BC. BQ by BC, which is AP by so which is nothing but, if I do this operation, negate both of them, so you will get minus AP by AC is equal to minus BQ by BC. And why am I doing that? You will now come to know. Let me again take this diagram to here. So let me say, yeah. So this is here now. Now, why did I do that? Now you'll see. Now I'm in the next step. What I'm going to do is I'm going to add 1 to both. So AP by AC is equal to 1 minus BQ by BC. So what is this now? This is nothing but AC minus AP. Or actually, this itself is a good point to say that PQ is parallel to AB, PQ is parallel to AB, but then since we have taken this as a destination, so you could have also taken this as destination. So CQ by CB is equal to CP by CA is equivalent to saying that
So we can't hear you.
So your audio's gone.
YouTube also is gone. So we can't hear you.
Hello, guys, you're there? Hello.
Yes, sir.
Yes, sir.
Yeah, sorry, just got disconnected. Some power failure here. So, is the YouTube stream also on?
So it still is.
Is it? I think I don't know.
It is, sir.
It is,
Yes, sir.
but I have to share the screen. Wait a minute. Hmm. Just a minute. So where is it? I don't know. Yeah. Give me a moment, okay? Yeah. Yeah, guys, you're there? Hello? 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 Hello?
Yes, sir.
Yeah, you're there, right?
Yes, sir.
So let me just share the screen so that, yeah, becomes, yeah. Is the screen visible now?
Yes, sir.
Hello?
Yes, sir.
So it's visible now.
Okay, cool. So yeah, so did you understand this? So this is what we were discussing, and hence eventually you can do this as well.
So they're telling that they can hear but they can't see on YouTube.
Now it will take some time. Actually, there's a little bit of lag, so never mind. So AC minus AP upon AC minus AP upon AC is equal to BC minus BQ upon BC. So this is what we intended to find out, isn't it? This is what we intended to find out, and hence this was what we intended to find out, and this is CQ upon CB. Sorry, this will be nothing but AC minus AP is CP. So CP upon CB is equal to CP upon CA. Sorry, what is that? CP upon CA. I'm really sorry. CP upon CA from here is equal to CQ upon CB. Now, what is the learning of this problem? Learning from this problem is that, okay, you first ascertain where do you want to go. So let's say if I want to go, I have to prove this PQ is parallel to AB, then my first thing which comes into my mind is, okay, can I use BPT somehow to get to this? And that's how we started. Okay, so and then we recollected the basic proportionality theorem, and then we tried using that theorem, and then eventually got to this result. So this is how you have to think. Now, moving ahead, there is a there is something related to this is not something called midpoint theorem. Now, as I have repeatedly been telling you that what you guys can do is you have a separate sheet. You please have a separate sheet where, yeah, so what you can do is midpoint. What I was telling you is there is a very good habit of having a separate sheet where you list down all the theorems and results at one place. Even let's say if there is a good question in the examples, or let's say exercises, you should take down that as a good, let's say in one sheet you should write all of them together and use that as a reference whenever you are solving problems. So there is no problem in having the reference there, and then solving, keep solving problems with the reference on. You keep the reference in front of you and solve. So coming back to this, so midpoint theorem is related to BPT only. So let's say A, B, C. is my triangle, and let's say there is a line joining D. D and E are the midpoints of AB and AC respectively. So I'm saying DE is midpoint of D is D is the midpoint of AB, and E is the midpoint of AC. Okay. Yeah. Is this yeah? Is it visible in the YouTube as well? I'm not sure, guys. Do you think it is? Yeah, people are able to see it. Guys, you're there, Harshit?
Yes, sir.
Samrat?
Yes, sir.
Yeah. So are people are able
So
to
how do
see
we
it?
check that?
I'm sorry.
So how do we check that?
Oh, never mind. So those who are already there can check it. Never mind. So yeah. So yeah. So Ronak, if you are listening to me, I can see that you're there. So is it proper? Yeah. Okay. So are you able to get the feed, right? Because in my feed it is showing something else. Never mind. So yeah. So now what I'm saying is D is the midpoint of AB, E is the midpoint of AC, and that again that line joining this is parallel to BC, and actually DE is parallel to BC, and DE is equal to half of BC as well. So this is what is the midpoint theorem's statement. Okay, so nothing big deal in it. You can use your BPT to prove, and yeah. So basically, so midpoint theorem I will write also, so that those who but you can check it from the book as well. So it says that the line joining midpoints the line joining midpoints of any two sides of a triangle is parallel to the third side, and the next step is that that side DE is half of BC. So yeah, so by the converse of BPT will be used here. Why? Because the ratios are same, isn't it? So if you see D is the midpoint, so we know that we can easily say that AD is equal to DB, and hence AD upon DB equals 1. Okay. Similarly, AE upon EC will also be equal to 1, because E is the midpoint of AC. So hence from 1 and 2, I can infer that AD upon DB equals AE upon EC. And this is where this is a prerequisite of basic proportionality, converse of basic proportionality theorem. And so hence by converse of BPT, I can say that DE is parallel to BC. Okay, this is parallel to BC. Perfect. Now, okay. Now let me give you a question onto you. Wait a minute. Okay, but the other thing to be proven, proven is, how do you prove that DE is half of BC? Yeah, you remember we have to do a construction, and we can use congruences to do that. What was the construction? I am just leaving this as a practice for you, but I'll give you the hint that you need to.
There's some questions on YouTube.
Sorry, there's a question, is it?
Yes.
How do you prove that it is half? Okay, never mind. So let me do that. So yes, Harshit, how do you prove that it is half? So what construction do I need to do? I need to either you extend DE to E, let's say EF, okay, and join FC. Join FC. So what will happen? So I have extended DE to EF and I have joined FC. So this side is equal to this side because it's given. This side is equal to this side by construction, and this angle will be equal to this angle because they are vertically opposite angles. So hence, what do we infer? Anyone can tell me what do we infer from this? Bolo
It's
guys.
congruent by SAS.
Yeah, so it is. So and hence we figure out that, and I'm writing here in black that triangle ADE is congruent to triangle C. Then what? CFE, isn't it? Isn't it? So hence, what will happen? Yeah. So what will happen? It means that.
So CF equal to AD, but AD
Yeah,
is equal
CF,
to DB. So
right.
CF equal to DB.
Yeah. So basically, CF is equal to. For this will give you CF is equal to AD by CPCT, congruent parts of congruent triangles. So CF is equal to AD. That means CF is equal to BD. CF is equal to BD. Yeah, CF is equal to BD. And secondly, this will also give you that this angle will be equal to this angle by, again, CPCT. So I'll write angle FCE is equal to angle ADE. And hence, if you see they are same, that means AB is parallel to FC because alternate interior angle. This is alternate interior angles. So hence, what do we get? We get that AB is parallel to FC. Now AB is parallel to FC. That means this implies DB is parallel to FC and DB is equal to FC as well. DB is equal to FC as well. We just proved here. DB is equal to FC. That means what? DBCF is a parallelogram. Ojasvi, until unless we, so there is, I discussed this in the class as well. The question is, why can't we use similarity to prove this? Now, as I told you that, the sequence of one theorem is based out of some theorem. Let's say theorem X is based on theorem Y, and theorem X the proof of theorem X lies in theorem Y. Then you cannot use theorem X.
Question on YouTube.
I'm sorry.
There's another question on YouTube.
Yeah, that's the question. I'm trying to answer Ojasvi's question. Question is, why can't we just prove similarity of the two triangles since they are parallel? So that's what I was saying. That similarity is based on. So if you will see that the conditions of similarity are based on basic proportionality theorem. So hence we cannot use the other way around. Do you understand that point? So if that's what I was saying. If the proof of theorem X depends on theorem Y, you cannot use theorem X itself to prove theorem Y. So that's the rule. Okay, now DBC is a parallelogram. DBCF. So hence, because after this, the logical thing is we will go towards similarity. So hence, so DBCF is a parallelogram. So when DBCF is a parallelogram, what do we see or what do we observe? DF is parallel to BC and DF is equal to BC. Now DF is nothing but twice of DE because again DE was equal to EF. So this is DE equals BC. Hence DE becomes half of BC. Proved. Okay. So this was theorem number 2. What did we learn so far? Basic proportionality theorem, converse of basic proportionality theorem, corollaries to basic proportionality theorem, and then midpoint theorem. And then there is something called now angle bisector theorem. What is it? Angle bisector theorem. This is again very important. Angle bisector theorem. And now in the class I had discussed there are two types of angle bisectors. One is called internal angle bisector, internal angle bisector, and the other one is called external angle bisector. So let's understand quickly what is internal and external. So basically internal angle is, let's say I have to draw a triangle. So let me draw a triangle. Okay. Now let's say this is ABC is the triangle. And let's say this, guys, give me a minute. Just put it here. So close this. Where is it? It's already there. You're live. Put it off. Now, yeah, continue. You go and share your screen. Where is the screen? Where are you writing? Oh, wow. So, share. Carry on. So, yes, guys. So, yeah. Now, what is an internal angle bisector? Internal angle bisector is this. So, if you have this line, this angle is equal to this angle. Okay. So, this is internal angle bisector where the bisector of an internal angle. So, hence it is called internal bisector. Internal bisector basically. So, all the three angles can have one internal bisector. Let's say this is D. Now, internal angle bisector theorem says that prove that the internal bisector of an angle of a triangle divides the opposite side. So, what is internal angle bisector theorem says that the internal bisector internal bisector internal bisector of an angle 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 of a triangle of a triangle of a triangle divides the opposite side internally in the ratio guys, just a minute. Hello. I'm doing that. Yeah. Internally in the ratio of the sides containing the angle. So the statement looks a little heavier, but then I'll explain. Containing the angle. So basically, what are they saying is they're saying this. What are they saying is the internal bisector of an angle of a triangle divides the opposite sides internally. That means this upon this is equal to this upon this. So basically, they are saying if AD is the bisector, then AB upon AC is equal to BD upon DC. This is what they are saying. Okay, and the proof again we have done. What you need to do is you need to produce AB such that AC is equal to AE. So let's say produce BA to E such that AB is equal to AE and join EC.
We can't hear you. Hello, is anyone there?
No, it's not there. No, it's not there.
Fine, fine, fine. Yes or no? We can't hear him.
Can you message?
I don't have access to WhatsApp.
Does anyone know what happened? Does anyone know what happened?
So I left.
Thank you for nothing.
Bro, Anirudh, we're live. Don't do that.
What?
We're live. Don't show your camera.
Yeah, I switched off the camera.
You.
No, both of you
Still
calm
seen,
down.
is it? One sec.
But we can't see you. You chill now.
Bro, what shirt are you wearing? Oh wait, he left.
Where is sir?
How do you connect?
Can't hear you. Just type Tarachir.
You connect from YouTube? Samrit, don't spoil the joke, da.
Go to YouTube and search Centum Academy.
Is the chat available?
Yeah, yeah.
Is the chat shown? Our chat?
No.
No.
Is class continuing or what?